Hello friends, myself Dr. Nandakumar Raubawale from College of Engineering Ambazobe is going to deal with Applied Thermodynamics 1. This is our 46th lecture. In previous lecture we have discussed about condition for minimum work done, actual indicator diagram, work done and indicated power required to run the compressor, and the classification of rotary air compressor and working principle of rotary air compressor. So now today we will discuss about numericals on air compressor. Very first numerical is determine size of the cylinder of a double acting air compressor. Size means we have to find out diameter and stroke length of air compressor of 32 kilowatt indicated power. Indicated power is given as 32 kilowatt in which air is drawn at 1 bar. So pressure P1 is 1 bar and compressed to 16 bar pressure means P2, pressure P2 is 16 bar. According to the law, PV raised to 1.25 means small n value is 1.25 and the revolutions per minute, speed at which it runs, rotary speed is 300 rpm and the linear motion of piston is 180 meters per meter and volumetric efficiency is given as 0.8. So we'll collect this information. So indicated power is 32 kilowatt. It is double acting. So here it is given as double acting. So this is not a single acting, it is a double acting air compressor. Then this is important parameter which is given here, double acting air compressor. Then inlet pressure is P1, delivery pressure is 16 bar and the index of compression or expansion is n is equal to 1.25. Number of cycles per minute is 300 and piston speed is 180 meter per minute and volumetric efficiency is 0.8. And he is asking us to find out diameter and stroke length. So diameter and stroke length is available in one formula, that is swept volume. Swept volume is given by pi by 4 d square L. So first of all we must calculate swept volume, and out of these two, diameter and L, one we have to find out. So this piston speed which is given is a linear speed, linear piston speed. So linear piston speed is given by 2L into RPS. So piston speed you will get in per minute, meter per minute. So here meter per minute is given, meter per minute is given. So here this has to be substituted in meter per second because here revolutions per second is there. So then from this piston speed is known, revolutions per minute is known, only L can be obtained. So L we can substitute. Now our aim is to find out swept volume. So volumetric efficiency is given. From volumetric efficiency, if we know actual volume, we can find out swept volume. Volumetric efficiency is known, actual volume if we know, and if we substitute actual volume in this case, then we will get swept volume. So swept volume is equal to actual volume divided by volumetric efficiency. So our aim is to find out actual volume. So indicated power is known. So formula to find out indicated power for double acting air compressor is known. So N is given in this problem. P1 pressure at inlet, VA is unknown which we can find out. P2 is known, P1 is known, revolutions per second is known, S2 is constant, 1000 is known. So very first using this equation of indicated power we can find out VA, then this VA can be substituted here. Volumetric efficiency is given, swept volume can be obtained, swept volume is known, this can be used here, and knowing this piston speed we can find out L. L can be substituted here, unknown will be D and D can be calculated. So we have to start this solution of problem from bottom to top. So let us start how to solve this problem. So indicated power for double acting air compressor is given by N divided by N minus 1 P1 VA in bracket or 2 times RPS, revolutions per second, divided by 1000 in bracket P2 divided by P1 to the power of n minus 1 divided by n minus 1, close this bracket. Indicated power is given to us, so we will substitute indicated power here. It is 32 kilowatt. We can see indicated power is 32 kilowatt, 32, which is equal to n is, again n value is 1.25, 1.25 divided by 1.25 minus 1 into P1. Inlet pressure P1 is given as 1 bar 1 into 10 to the power of 5 into VA. This we want to find out, into 2 times RPS. RPS is not given, so RPM is given, revolutions per minute. RPM in 1 minute divided by 60 is nothing but RPS. So 300 divided by 60, 5 RPS, revolutions per second. RPS is 5 divided by 1000 in bracket P2 divided by P1. P2 is 16 bar divided by P1 is 1 bar to the power of 1.25 minus 1 divided by 1.25 minus 1. Then from this we can get a VA as 1730 into 10 to the power of minus 6 meter cube per cycle. So this is VA. So now VA is known, actual volume taken by this compressor. So we know volumetric efficiency is equal to actual volume divided by swept volume, or this swept volume, this can be written like this: swept volume Vs is equal to VA divided by volumetric efficiency. So VA is known, 1730 into 10 to the power of minus 6. Volumetric efficiency, which is given in this problem, is 0.8%. 80% means 0.8, so divided by 0.8. So this is going to give us the swept volume as 2162 into 10 to the power of minus 6 meter cube per cycle. So swept volume Vs is given as 2162 into 10 to the power of minus 6 per cycle. Now we know piston speed. Piston speed is equal to 2L into RPS. Piston speed is given in 180 meters per minute. So we have to convert it into per second divided by 60. So this is important. Why we are dividing it here by 60? So it is 180 meter per minute. Minute has to be converted into second. That's why we are dividing it by 60. 2 into L into RPS is 5. So from this we get stroke length of compressor as 0.3 meter. So once we know the stroke length of a compressor, so we can use this equation: Vs is equal to pi by 4 d square L. So Vs is known, that is 2162 into 10 to the power of minus 6, which is equal to pi by 4 d square. L is nothing but 0.3. From this we can get d value as diameter of this compressor as 0.096 meter. So diameter of piston is 0.096 meter. This is how we get the solution. So first we find out indicated power. From this we get VA, and this VA we substitute in a volumetric equation, we get Vs. So this Vs, again from this piston speed which is given, we find out L. So L and Vs we substitute in this equation of swept volume. and from that we get diameter as 0.096. So answer is L stroke length is 0.3 meter and diameter D is equal to 0.096 meter. This is the solution for this problem. Now coming to the second problem. Again here it is given single stage, single acting. It is a simple compressor, single stage and single acting compressor delivers 15 meter cube of free air per minute. The free air delivered is 15 meter cube per minute from 1 bar to 8 bar. The speed of compressor is 300 rpm. Assuming that the compression and expansion follow the law PV raised to 1.3, n is equal to 1.3 is equal to constant. Clearance is 1/10 of shaft volume. Vc divided by Vs is 1/10. Find the diameter and stroke length of compressor. We have to find out D and L again. Take L by D ratio as 1.5. The temperature and pressure of air are same as atmosphere at the inlet, and also find indicated power of compressor. So first of all, we will collect this information. So compressor is single acting, single stage, free air delivered is 15 meter cube per minute, inlet pressure is 1 bar, the desired pressure is 8 bar, the compressor speed, rotary speed is 300 rpm, the index for polytropic compression and expansion is 1.3, that is n value is 1.3. Then it is given that the ratio of clearance volume to shaft volume is 1/10 and L by D ratio is 1.5. So he is asking us to find out diameter and stroke length. So here, if we know shaft volume, we can find out diameter and stroke length, because this L by D gives us L is equal to 1.5 times D. So L can be substituted, this equation gets converted into diameter. If we know shaft volume, then directly we can find out diameter. So here this shaft volume we have to find out. Free air delivered per minute, VA is equal to shaft volume divided into volumetric efficiency into RPM, revolutions per minute. So how this we get as volumetric efficiency is equal to VA divided by VS. So this VA divided by VS. So actually this unit of VA is meter cube per cycle. So meter cube per cycle, but here this VA free air delivered is given in meter cube per minute. So this how we get meter cube per minute. If we multiply this meter cube per cycle into cycles per minute, then we get this. Free air delivered VA per minute is nothing but Vs into volumetric efficiency, Vs into volumetric efficiency into RPM. Then this is in meter cube per minute. So this actually RPM is not there in this equation, even though we are multiplying this by RPM, because this Vs we want to convert into meter cube per minute. So here VA is in meter cube per minute, therefore we are multiplying it by RPM. If this VA is in meter cube per cycle, then we need not to multiply by this RPM. Now from this we get VA. So to know VA, we must know Vs and volumetric efficiency and RPM. So here volumetric efficiency can be obtained by 1 minus Vc divided by Vs into P2 divided by P1 to the power of 1 over n minus 1. So this equation we have derived. So we know Vc divided by Vs ratio as 1/10, that is 0.1. P2 we know, P1 we know, n value we know, volumetric efficiency can be obtained. So this volumetric efficiency we can substitute. RPM is given, volumetric efficiency is given, and VA is given. So VA is also given. So from this we can find out Vs. So this Vs helps us to find out the dimensions. So once we know Vs, we substitute it here and we can find out d and l. And he is asking us to find out indicated power. So every data in this equation of indicated power is known. We can substitute it directly here and we can find the indicated power. So while starting this problem, we have to start with volumetric efficiency. First we find out volumetric efficiency, then we can find out this depth volume, how Va is known, RPM is known, Va can be known. So once we know Va is given, Vs can be known, this Vs can be substituted here and D and L can be obtained first. So we have to start with volumetric efficiency. So now volumetric efficiency of compressor is given by 1 minus Vc divided by Vs bracket P2 divided by P1 to the power of 1 by n minus 1. So here 1 is known, Vc divided by Vs is given in problem, that is 1/10. P1 and P2 is known. P1 is 1 bar, P2 is 8 bar, 8 divided by 1 to the power of 1 divided by n value is 1.3 minus 1. So this volumetric efficiency works out to be 0.75, or that is 75.3%. Once we know volumetric efficiency, so this we know volumetric efficiency is equal to Va divided by Vs. We know this. Now Vs is equal to Va divided by volumetric efficiency. Vs is equal to Va divided by volumetric efficiency. But Va, which is given in this problem, is in Va given in this problem is in 15 meter cube per minute. This is in 15 meter cube per minute. And this Vs which we get, so now Vs is equal to Va is 15 divided by 0.8. So this works out to be 150 divided by 8 is 8 1 8, 7, 18.7 meter cube per minute. So Vs we get as 18.7 meter cube per minute. But this formula for Vs, which is given as Vs is equal to pi by 4 d square L. So this Vs is in meter cube per cycle, and the Vs which we have obtained is 18.7 meter cube per minute. So this meter cube per cycle and this is in meter cube per minute. So Vs is equal to pi by 4 d square L into cycles per second, that is RPM divided by 60. So Vs value is known. Now this becomes meter cube per minute, because this is meter cube per cycle and cycles per minute. Cycle gets cancelled, meter cube per minute. So Vs value is 18.7, which is equal to pi by 4 d square L into RPM. RPM given is 300 divided by 60. So here one more thing is given. in this problem. L is equal to 1.5 times D. L is equal to 1.5 times D. So here L is equal to 1.5 times D. So substituting this 18.7 is equal to pi by 4 D square. In place of L we substitute 1.5 D into 65 or 300 into 5. So when we simplify this, we get diameter D equal to 0.383 meter, and L equal to, if we substitute D in this equation, L is equal to 1.5 D, we get L as 0.587 meter. So this is about the dimensions of compressor. Now we want to find out indicated power for this single stage single acting air compressor. Indicated power is equal to N divided by N minus 1 P1 VA divided by 60. So this 60, why this 60 we will discuss, into P2 divided by P1 to the power of N minus 1 divided by N minus 1 into 1 over 1000. So how this equation we have written? So actual equation is indicated power is equal to N divided by N minus 1 P1 VA into RPS divided by 1000 bracket P2 divided by P1 to the power of N minus 1 divided by N minus 1. So this is the equation. So here RPS is not required, because RPS is, why RPS is not required? If this VA if this VA is in meter cube per cycle, then we have to multiply it by cycles per second or cycles per minute, and then we have to divide it by 60. So here already this VA is in meter cube per minute. Just if we divide it by 60, it will be in meter cube per second. So therefore cycles per minute is not required, or cycles per second is not required. So this term is not required. Directly it is in meter cube per minute. So divided by 60, it will be in meter cube per second. So this is divided by 60 and RPS is absent here. And divided by 1000, already here divided by 1000. So now substituting these values in equation number 1, say first equation, the indicated power N is given, index of compression is 1.3 divided by 1.3 minus 1 into P1 is 1 bar. 1 bar means 1 into 10 to the power of 5 into VA. VA value is given 15 meter cube per minute, so directly 15. If this VA is given in meter cube per cycle, then we have to multiply it by RPS. So divided by 60, because we want to convert this meter cube into meter cube per minute into meter cube per second, into P2 is 8 divided by 1 to the power of 1.3 minus 1 divided by 1 minus 1. So on simplification we get this as 66.4 kilowatt. Indicated power is 66.4 kilowatt. So this is how we get the solution for the problem. Now we move to the next problem for today's lecture, third problem. Here a single stage, again single stage but double acting air compressor of 62.5 kilowatt indicated power. Indicated power is given at 200 rpm. So N is equal to 200 rpm. Indicated power is 62.5. Takes air at 1 bar, delivers at 10 bar. Assuming law of expansion and compression is 1 P to the power of 1.35, means N value is 1.35. 3.5. Find the diameter and stroke. D and L we have to find out. Take piston speed 200 meters per minute. This is linear speed. Volumetric efficiency is 90%. Also find clearance volume as a percentage of stroke length. Clearance volume as a percentage of stroke length or stroke length. Now we'll collect this data into the table. Indicated power is given. RPM, revolutions per minute, is 120 RPM. You can see 100 RPM. 200 RPM. RPM is 120. This is not 200, 120 RPM. Question is wrong. We take RPM as 20, 120. No, N is equal to 120, P1 is equal to 1 bar, and P2 is equal to 10 bar, and volumetric index is 1.5. Piston speed is 200 meters per minute, and volumetric efficiency was given as 90%. Here we have taken it as 0.9. So we have to find out D, L, and ratio of clearance volume to work volume. So now, if we want to find out D and L, we have to take this equation. In this equation, we can find out as the piston speed is given, RPM is given, L can be obtained, and this L can be. So after that, we don't know Vs. To find out Vs, we can use this volumetric efficiency equation. Volumetric efficiency is equal to Va divided by Vs. So volumetric efficiency is given. Now, if we find out Va, then directly we can find out Vs. So here, Vs. Va can be obtained in this equation. Indicated power is known. Indicated power is known. N is known. P1 is known. Va is unknown. 2 divided by P1. P2 is known. P1 is known. N is known. RPM is given. So from this Va can be obtained. So this Va can be substituted here. Vs can be obtained. Vs can be substituted. D and L can be obtained. So this is how we can find out this D and L. And he has asked us to find out this. So Vs divided by Vc divided by Vs. Volumetric efficiency is known, pressure ratio is known, N is known. Directly by using this another equation for volumetric efficiency, we can find out Vc divided by. Let us start to solve this. Very first, indicated power equal to N divided by N minus 1 P1 Va into 2 times RPM divided by 60. RPM divided by 60. RPS 2 RPS into 1000 to convert it into kilowatt. Bracket divided by P1 to the power of N minus 1 divided by N minus 1. Close this by. The indicated power is given as 0.5 kilowatt. N value is known, that is 1.5, which is given in the problem. N is equal to 1.5. 1. P1 is 1 bar. 1 bar means 1 into 10 to the power of 5. So we want to find out Va into 2. RPM is given as 120 divided by into 1000. 20 bracket. P2 is again 10 bar. 10 divided by 1 to the power of 1.5 minus 1 divided by 1.5 minus 1. So if we simplify, we get Va as 5.73 into 10 to the power of minus 3 meter cube per cycle. Per cycle, because here we are multiplying it with RPM. So this has got per minute. So volumetric efficiency is equal to VA divided by VS. So we know VS is equal to VA divided by volumetric efficiency. A is 5.73 into 10 to the power of minus 3 whole divided by volumetric efficiency is given as 90%, means 0.9. If we divide it by 0.9, get this as 0.637 meter cube per cycle. So Vs is known. Now once we know Vs, so piston speed linear piston is equal to L into Pm. So now this piston speed will be in meters per minute. So piston speed is given as 200 meters per minute equal to L into RPM. Here also revolutions per minute, here meters per minute. Meters per minute, revolutions per minute. Therefore, we need not to divide it by 60. RPM is 120. From this, we get L is equal to we get as 0.834 meter. L we know. L value is known. So now coming to this Vs equation, Vs is equal to pi by 4 P square L. Vs value is known as 0.00637, 0.007, which is pi by 4 P square into L value is known. L value which we calculated as 0.834. From this we get diameter D as 0.002. So this is for diameter. L is meter. Then we want to find out ratio clearance to surf volume. Volumetric efficiency equal to 1 minus Vc divided by Vs bracket 2 divided by 1 power of 1 over n 1. The equation volumetric efficiency is known to us 0.919 divided by Vs we want to find out. Bracket P is 10 bar divided by P1 is 1 bar to the power of 1 divided by 1.5. N is equal to 1.35 minus 1. Close this bracket. So finally on simplification divided by Vs we get as 19 point. Sorry, this initially we get as 0.199. In percentage, this can be written as 99%. This is how we obtained. Answer says D is equal to 0.009. L is equal to 4 meter divided by D is 19. Volume to surf volume.